Yeah, so hello, good evening, everyone. And then
Good
today we are
evening.
just going to continue where we left off in our previous class. So let's get right into it. I'm going to share my screen. Share my screen, and then, like we know, we are using. We know that we are using Jupyter Lab. So let's start our server. Jupyter Lab is going to start, and then our browser is going to open automatically. Right. So today we are going to use notebook, and then we are going to call our notebook a new name. Um, let's call it visualization. Visualization. Right. Okay. So we know the libraries that we normally use. We import pandas as usual as PD. We import numpy as np, and then we import matplot as plt. Let's see if everything is in order. Okay, great. Okay, method plot method okay. Okay, what am I writing wrong here? What is wrong? What is wrong? What is wrong? Yeah, that plot library. Okay, so this, yeah, then we should be good now. So the idea today is to we have imported all the three commonest libraries that we use in data analysis that we have spoken about so far. So we know that for us to use this, like any of these, we have to like have a data set we are working with. So the first thing is to load data into our environment, into our notebook. So load data into notebook. Then how do we do that? We define that using, of course, our data frame. So we know we use that. We do that using PD, which is Pandas. So we are going to be loading a CSV file. So I have a CSV file. Let me check in here, and then the name is what again now? The name is. Let me see. Okay, let me just dot CSV. Yeah, the name is this. Okay, so this is a CSV file now. Uh, let's do. Trying to see if I can get the file path. The file path to our CSV. So I know the name of the CSV is ice cream rating. So if I do this, put this in here, and then I know that this is in download, and then my file is in this folder. My file is in this folder, the same as download. So I can say downloads slash ice cream. This is my ice cream rating dot csv. So let's see if this helps. So let's run this. Okay. wrong. I have a wrong part. So it's saying that no such directory. So obviously this is my file. This is my folder. I know that this is in here. So if I do this, see error. Okay. In that case, I use an absolute part. Okay, I don't know what's wrong. Let's do something quickly to find a part of our file. Please interrupt me at any point if you do not understand what I'm doing. So what I'm trying to do now is get the file part. So I'm in the same folder. The folder I'm in here is where I'm here too. So this is my visualization notebook. Now I want to get the part to the data I want to use. So I will cd into downloads, and then if I list and say ice cream, right? So I know that my file is in this folder. So if I say wpd, this is the part of the folder. So I can copy this and then put it in here. And then when I run this should work as expected. Okay, what's wrong now? What's it saying? No such file directory. Okay. Oh my god. Oh, okay. I had a different issue. Yeah, so I guess this should have worked. I was the one who made a mistake. So yeah, this actually worked. So I was wondering why it didn't work. So this should have also worked. You see? So this is our data set. So this is our data set now. We see that we have 1, 2, 3, 4, 4 columns, and then we have 6 records, 6 rows. So column by row, this is 7 by 4. It's actually 7 rows, right? So what we want to do is, this is a very minimal data set. We just want to plot using the various data representation plots or charts that we have in Metasploit. So yeah, let's get into it. Well, the first thing we'll do is set our index. So we say df is equal to df.set index. Then our index here is going to be the date. Because date is more granular. It's like 1, 2, 3, 4, 5, 6, 7. So it is none of the data is missing. It is what's it called? It is progressive. So that is why we're using this. So run this, everything should be fine. So if I get the data, but I still have my data, but we see now that instead of using the SN serial number, is using date as the index now. Right. So again, the idea is to know enough tools, enough libraries, enough methods when you are using this, so that when you need to solve a problem, you hope that you know something that will help you achieve solve the problem you're trying to solve. Okay, so now let's proceed to actually plotting. So we have df.plot. Let's see, will this go as expected? Yeah. So we have this plot. We have interacted with a plot like this before at the beginning of this class, and then this should look very similar to that. So we have how many lines here? One, two, three. We see the orange line, we see the blue line, then we see the green line, and that makes sense because now we have three three data columns. So one of these is flavor rating, and then we see the legend here. The legend is saying that the blue line is the plot for the flavor rating column, and then the texture rating is the orange line, and then the overall rating is the green line. And I mean, we can zoom into this, we see that our date is plotted on the x-axis, while automatically choose a data spread for our y-axis, right? So it goes from 1, so the difference, the interval between them is 2.02. So from 1.0 to 0.8, so 0.6. So, and then it chose this based on what is more in line with our data spread. So that is that, and then we even go ahead, and what plot allows us to do is that it allows us to define. So plot is going to be the basis to define the various kind of um, uh, graphing or chart we want to use. So for instance, I can go ahead and say df.plot, and then can define a chart kind, and then now we want to use lines. Now the question is, what we are going to get different from what we already get, because this already seems like line. But let's find out. Boom. So see that it is still line, which means by default plot uses the kind of plot that plot uses is line. But the interesting thing is we don't have just line, and then say that we want to have more overview or insight into what is going on here. For instance, say we have like 50 columns here, and this could be really messy, especially if the deviation between each of those columns is not really obvious. Then we'll see that the lines might overlap a lot, and then you might not see, some of the line might be oblivion at a glance. So how do we do that? How do we separate the lines into each graph? So we could do df.plot, and then we'll do our kind is still line. Alright, but now we want to do subplots, and then we see that is true. Our subplot is going to be true. So we run this, what do we have? So now we have separated our plot into the various plots. So this is for flavor rating, this for texture rating, and then this for overall rating, and then the graphing is still the same. That has not changed. Is someone raising up their hand?
Yeah, me. Tama,
Okay.
please, after the class, can you send the code as well?
Okay, sure.
Oh,
I'll do
thank you.
that. Okay, so now we have separated the graph into different subgraphs, which means if we had like 50 columns, this all of the columns will have been separated into individual line graphs like this. So moving on now, we could also define a title, and then we could say df.plot, and then our kind is still line, but say that is default. We could say just title, and then we could say, we know this is ice cream data, ice cream rating. Let's run this and see what we have. Okay. Uh, oh, why am I getting this? Got an unexpected. Okay, yeah, was expecting title. Okay. Yeah, so now we have a title and then we are calling the title ice cream rating. Remember that we are still using line. The kind of chart we are using is line, and that is why we don't necessarily have to define it. But if I go ahead and define line, everything still works as same below, nothing changes, right? So the next type we want to consider now is the next thing I want to consider is and then we could, for instance, now we have label for our x-axis, but we do not have any label for our y-axis. We could label that. We could go ahead and do that by still doing our title. Title still remains as ice cream rating. We have our x label. X label should be still date. Okay, let's say daily rate. Daily ratings. Y label can be Y label could be scores. I mean, these are typical things that you expect a graph to have or a chart to have, right? So we see now that this is scores, and then this is called daily ratings. So moving on, let's explore a different kind of chart, and this kind is called bar. You know what a bar chart is, but let's see what that gives us. Now this is a bar chart. Same data, same spread. Now different chart representation. So what is this showing us? This is still showing us the three columns, and then we see the legend defining each of the column. So for this date, it's showing us the data representation for each of the column, and then same for the rest of the chart. Now another, just like we did for line, one option we could add to this is called stack. And then what does stack do? Let's find out. So this is showing line by line, side by side, which means it is not stack. Now when we say stack them together, and then we see that the spread has changed. So for overall rating is from this from 0.25 to almost 1 for 1/1/2022, and then flavor rating is 0 to 0.25, and then we see that texture rating is just around 0.25. So this is another representation that we can have, right? Great. Now say we just want to do for just one of the column. Now what do? We found out that we discuss how we can select just one column. This is our data still. Let's say we want to do for flavor rating and not the rest. We select this guy here, and then we run. We see that we get the data and that column. Now if we want to just plot this, then we can do this. Our kind still remains bar, and then are we stacking? Let's stack and see. Do we need to stack though? Yeah, we run into issues. Yeah, so we see now this is just for flavor rating, and then of course we could also single out the other columns like texture rating or overall rating, and then we have output like this. So let's assume we are not stacking, then what are we going to have with just one column? Same thing, nothing changes. Nothing changes, right? So So now nothing changes. So now moving on. I hope we are understanding. Please, you can by all means interrupt me if something is not clear. So let's move to a different kind of chart, right? So let's call this. This is called by chart. So now we still have our DF. Let's check our data. Our data is the ink chart, and then we want to plot on the data. And then we're doing the by, and then now we have start. Before then, let's see what this gives us. So this is what this gives us. So what does this mean? We know that we can have plot bar, and then that is going to be standing horizontally. Now for some reason you might require to have this, so slanting it hard this way. I definitely, I don't know why you would need this, but I'm sure there will be a use case for this. So we want to start this. We can already imagine what the output of this is because of what we had in the other guy. So still hands out, but I want to write all of this out. So without stack, and we stack, right? So that is that. So the next thing is we want to use a scattered plot or a scattered chart. So we say plot dot scatter, and then for let's do this. Missing two required argument xy. So for x equals, want to do texture rating, which is one of the columns, and then for y want to plot overall rating on y. Let's see what we have. So scattered, just what this allows us to do is show the deviation between our two data. So we have three columns, but we are deciding to see the deviation between overall rating and texture rating, and then so overall rating is plotted against texture rating, and then this is the spread. And then I think we could increase the size of uh, this size now. Size, let's say let's say 5. Um, 5. No, okay. Let's say S. Okay, yeah. So 5 is too small. Say 50. Yeah, you see it has become bigger, and then we can do 100, and then this has become bigger, and then we can also go ahead and even declare a color. Our current color is blue. Let's see black. Yeah, so we have black. Well, if black is boring for you, can go with a yellow, or I'm not sure if it's just primary colors. I'm not sure if it's just primary colors. So let's see purple. Just give me a moment. Yeah, yeah, I'm in class. Just give me a moment. I'll call you back. Yes, give me a moment. Sorry. So yeah, we see the way we can change the color. So we can change the color this way. Um, this is also possible. So I believe that so far it's been nice. So we have color, we have size. Yeah. So let's move to something else, and then now we want to discuss histogram. So just like we've been defining since, we still have idea of plot dot east. Then let's see what we have. So this is histogram. So histogram measures in frequency the how frequent um, a value occurs in a data spread. And then we could also do some things on this and define an argument that we call beams. We could say this is 5, and then we could say this is 10, and so on and so forth. I don't think this needs any further explanation because it just seems obvious. Right. There are some other weird charts, like sorry if they make sense to you for saying they're weird, but so this is like a box plot. What's it called? I think is it like a percentile chart, right? Like this is giving almost 40 percentile, and then from um, almost 90, right? Right. Doesn't make more sense to me, but if you need it, it is right there. Then we have area, and then we have, of course, a more popular chart, which is the pie charts. Mm. That requires either y column, okay, y column, okay, right. So there's a flavor rating. This is a flavor rating.
Flavor.
Ah, yes. Right. So this is the plot of flavor rating, and then we define a fixed size by this, and then we could say is so it's xy. So because if you say just 10, like if you increase it along the y, just the x axis, you're going to square the size, skew. So it's not going to work. So you have to like define the corresponding text value. So you see this as increase, and then you can make it a scale. So more interesting. So that is what I have up on visualization. Now I want us to move to something that I've spoken of before, and then that is called data cleaning. We have discussed the components on a more granular and technical level. What this is, what this looks like, but let's see it in action. How we make decision about what to remove and what to keep in our data set. So we do our normal imports, numpy as np, and then maybe for now we'll leave metaplot library out of the mix. But the important thing is that we always, when we do this, we work with data. So we need to bring our data into our environment, and how we do that is by doing this. So this is an absolute import, and then we know that it is in downloads, and right now I cannot remember the name of the file, but I can always check it out. I think it's an Excel file. As um, Okay, I cannot actually remember what I said. Just give me a moment. So this is ice cream written. No, I think it's customer data. Okay, yeah, this is it. So we know it is customer call list. Let's see what we have. We run it on issue. What is the issue now? No such file. Okay, customer call list. Oh, my bad. XLSX dot. So you have to put the extension. Okay, something is wrong still. Install. If we submodule, we have submodule graph plane, blah blah blah. So missing dependency. So it's asking me to install this, and then I know that I can get that done by doing pip install. So a new release is available, blah blah blah. Cannot find the version that satisfies the requirement. Oh, okay. Okay, so this is supposed to be a one-time installation. So now I can rerun my code again and hope that all issue is resolved. All issues are resolved. Now, yeah, it seems to be good. Let's see how far. Yeah, so this is how far now. So in here we have the customer ID, first name, last name, phone number, address of the customer. Um, is it a paying customer? That's a boolean um, column. Should we contact the customer or should we not? Is it useful? A useful column. So this is just to drive home some of the point. So the first thing is that you look at the customer ID. So we have a serial number. I want to make sure that we finish this. So we have a serial number, you see that it's consistent, and then you just take a quick look through your data. We have an ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 2022. So it is consistent, but now we see it seems that we have a duplicate record for Anakin Skywalker. Same record entered twice. So obviously we do not have a need for duplicate record because one record per customer, and that's to be unique. So the first thing we want to do is remove duplicate records. Remove duplicate records, and that we do that if you can remember it's something that we have discussed before, that we say df dot drop duplicate and we run this. Okay, something is wrong. Drop duplicates, we run this, and then boom, the duplicate is just gone. So we have just one instance of the Anakin Skywalker's record. So instead of 20 records now we have 19, just as we wanted. So that is the first cleaning. So you have this data and then you want to clean out things. So we see that the custom ID is now unique. There's no instance, we don't have a repetitive instance of any customer. So let's look at the first name now. So for the first name, we have Frodo, Abed, Walter, Dwint, no, John, Ron, Jeff, Sherlock, Gandalf, Peter, Samwise, Harry, Don, Leslie, Toby, Ron, Michael, Clark, Creed, Anakin. Everything seems to be in order. Let's go to the last name. Baggins, Nadim, / White. So we need to clean out the / Struth, Snow, Swanzin. So let's single out that out. We can say last name now. So last name seems to be dirty. There are undesirable characters coming with the data we are getting in that column. So we want to find out what these are and then find a way to remove them the most efficient way ever. So if you look through the data at a very quick glance, you see that we have this undesirable / you see this undesirable also. We don't want it, and then for this guy hyphen, we don't want that also. So this seems to be the three things we want to remove from this column to clean up the column. So the next question is, how do we remove those things? So one way to go about this is to first change this to a string. Right, so this is a string, and then you can strip it of unnecessary characters. And how do we do that exactly? So if you are familiar with, we have spoken about Python, and then I've said something in lines of Python having a data type called string. So if I say Python 3 and then I declare a string s and I call the string Omotola, I can find all the methods I can use on Omotola, and then we'll find out that strip is one of those methods I can use. So this is a variation of strip, but there's an actual strip. Strip. Can anybody find strip somewhere? Anyway. Yeah.
Check the last. Okay, we found
Okay,
it.
this is strip. So strip is supposed to remove characters you don't want from your string. So for instance, I have X and then I want to strip dollar of this character, and then if I say dollar is already a string, so if I say type of S, you see it's str, and then we want to say x dot strip. If I just run strip, it's not stripping anything because I didn't ask it to strip anything. But if I now say strip this character and I run it.
I'm sorry, I cannot see your screen.
Oh, you cannot? Oh.
Yeah. I mistakenly left the
Okay.
meeting and now I joined again and the face I'm saying.
Okay, can you see now?
Yeah.
So now I was saying that you have a string and then we know that we can, one of the methods you can use on this string is called strip. Abi? So if I say s.strip, I didn't ask you to strip anything, so it still returned back dollar to me. So now if I say I want to strip this character, I want to strip Omo, I have dollar less. So if I strip, because I strip Omo, I have dollar left. So now when I check S, I still have Omotola. If I strip, if I say s.strip every hole in the string. Why is it not stripping whole from your name dollar? So still, so if I say, for instance, if I say, most of the time it's used to clean out unwanted characters in a string. So if I say omotola, and then in here I have like art, in here I have like dollar sign, in here I have pound sign. Now I can say s dot strip every character of this sort, art, dollar, and then percentage. I don't know what's wrong with it, but you should get the point. The point is that I think I have 15 minutes left or more, and then I can say s dot strip this, and then it's going to strip. And then if I want to say I have this, and I say s dot strip this, it's going to strip that. So, and then I can use right or left strip and all of that. So now we have this, and then it's very interesting because when we check our data, we have the character is before, it's not in between. You see that when we use strip on characters that are in between our desired character, it's not doing anything about it. So now we want to strip all of this. So we want to strip, you check this, / is not supposed to precede to prefix a person's name, so we want to remove it. So we are cleaning that out. And then for Porter, we want to remove these 3 dots. We don't want that also. We are cleaning that out. And then for Fladensin, we want to remove underscore. So we are cleaning that out. So when we run our code, we see that it is cleaned out. So essentially, what we want to do now is to set our column, our last name column, to this name one. So once we do this, we clean that out, and then when we check our data frame, we see that our column is clean. So for phone number, we see that phone number is pretty dirty. We have in here we have / in between. We have pipe. We have not a number. We have not a number. Not of undesirable stuffs. So because instead of strip here, what we now use is replace. So we select the column because we want to deal with the column. Phone number, right? And then we know that we are going to be replacing it and updating it. So we want to say this dots, like I said, first change it to string, and then you replace. And then what are the things we are replacing? The first thing is you don't want the / So if I run this, what do I get? Okay, I run it on issue. Missing one argument. And what's the argument? Oh yes, we want to replace this with an empty string. Yeah, so when we check the df, we see that this had / it is now removed. So to remove the other ones now, we remove pipe. If I can find it on my keyboard, we remove not a number. So let's run this and see if it makes sense. Yeah, all of that's gone. So everything we have removed so far gone. So what are the other things that we need to remove? Okay, pipe is not gone. Why do we still have pipe? So why do we still have five? Okay, yeah, let's do a I think he wants to remove this, and then okay. So let's do one after the other and see if that works. So this, this. So the first thing is we want to remove 5. So remove 5. Pipe is gone. Also, what other thing do we want to remove from here? What other thing do we want to remove from here? Let's say we want to remove any.
NaN. I think I saw NaN at one point.
Yeah, so any n is just saying that it's not a number.
Okay.
Okay, let's say we want to remove any n to any n. Well, let's see. And then, so any n is just saying it's not a number. It's still going together. What else do we want to remove again? I think it pretty much looks okay now. Okay, I think we did a mistake. What we should have done is for the pipe, we should replace pipe with a dash. Yeah. So number 4, did it work? Let's reload. Number 4, it didn't work. But it doesn't matter. I just need it out of the place. So maybe we should remove all the dashes too. Just for consistency, right? All the dashes are gone now. This looks a lot cleaner. So the only thing we have left is the not a number. Right?
Yeah.
Not a number. So let's see what we can do with not a number. What do we want to replace not a number with?
A quick question.
Okay.
I don't know if you said that I missed it, but instead of writing the lines of code one by one, is there any way we can just write it in one single code?
Yes, definitely. So, I mean, we are going after in the real world. You want to group operations. You are doing together because you're in a notebook. It's like you're writing something on a paper, right? That is why it is like it is. But of course, having done all of this, you can put all your code together and run it, and then you have a new file. So we've never seen this file before. I've never claimed this file before. I'm just going after it one after the other. Do you understand?
Okay,
To
fair
see
enough.
what is dirty there, and then in the real world, this is the way I would go about it: removing undesirable characters from my file. Right. So this seems better than how we met it. Right. So we have address. Let's leave address for now. Not useful. Not useful is not useful for a reason. So let's drop it. And then if you remember how we drop column, is simply df.drop, and then we define the column once it drop, and then we run it. Okay, we run it. Say show. So how do we draw column again? Okay, I think we can select this. I don't know. Okay, so why am I not? Why is it not dropping? Drop. I'm trying to drop it. Why are you not dropping? Not useful. The spelling is right. My just okay. Let me just check our earlier files. Pandas. Okay. Okay. So I'm dropping. Okay, I'm dropping in place. Exactly. And that's what I did initially. So why is it not dropping? So the drop. I'm dropping this guy. Why is it not running into issue? Saying not found in axis. Okay, so axis is equals to 1. Axis is equals to 1. Any issue still? And then in place equals true, if I remember. Axis equals to 1. In place true. Okay, what's going on right now? Not useful column. Okay, fair enough. I mean, it is code. How are we going to know it's code if you're not running into issue, right? This is not working. So what's not the issue exactly? We already have. It's okay. And let me do this. So if I do this now, drop this here. Does that make any difference? Oh, okay. Oh, okay. So why is it not dropping down there? Whatever. So I mean, the point is to drop it all this one. So now it was able to drop up here. Not useful column is dropped. So if I reload this, I should not see this anymore because I've dropped it up there. Oh, okay. Let's just say df equals this, and then I do this. It should be done. Exactly. Gone. So all the dfs are now updated. Exactly. Sorry for the hold up. Sometimes all of this thing happens, and then I reload this, and then exactly gone. And I can delete this. Yes. That was a tough one. So for so that's that we remove that paying customer. So we have yes, no, and so we want to make sure that this is consistent. So um, how do we do that now? So how we do that is we select the column. It's either we change it to a yes or no column, or we change it to a y or n column. So we have and then we can see that this first of all, like we do, change it to a string and then use replace, and then you want to replace all yes to y. Your choice though. I mean, want to replace all yeses to y, and then you want to replace all no's, all noses or nose. I don't know if nose or noses are correct, to n from consistency. So when you check your data frame now, it should make more sense than. So now, yeah, so we have consistent data y n, and then you want to replace any with nothing. You don't need any with an empty string, and then okay, not any is n or slash a. Right, so makes sense now. So the last column now is do not contact. We say that this is also like do not pay.